Assalamualaikum warahmatullahi wabarakatuh and hello to everyone. Today we will present our group project which is titled is Technique of Differentiation. We are from group 3 from class 2G. Before we begin, allow me to introduce our group members. Okay, first we got Muhammad Akil Ashraf bin Hamri. Second, Muhammad Zafran Zaim bin Muhammad Arif. Third, which is me, Muhammad Junaidi Akbar Muhammad Sharum. And lastly, Muhammad Farid bin Zainuddin. For question 1, clarify the significance of differentiation and its application. For the significance of differentiation important in rate of change because it can simply measure of instantaneous rate of change. Next, differentiation can finding the curve slope, whereas differentiation can find the slope of a function at any point and can be used in the curve of tangent line. Lastly, differentiation can be used in optimization, where it can find and identify the maximum or minimum value of a function. Next, for its application, differentiation can be used in physics because differentiation helps determine velocity and acceleration by finding the rate of change of position with the respect of time. Next, differentiation also can be used in economic, which is differentiation can be used to find marginal cost, marginal revenue, and crucial for making profit, maximizing decision. Lastly, differentiation also can be used in computer graphic because differentiation can help in rendering smooth curve and adjusting brightness gradient.
Hello, my name is Muhammad Farid bin Zainuddin. Today we're going to take a look at the question from the topic Technique of Differentiation. We got question 2 here. The question asks us to find the derivative for the following function. So for the function that given to us is gx equal to square root of 3 7x squared plus ln 5x. To solve the equation, we're going to use a chain rule. So for the first step, we're going to transform our square root of 3 to the power. So we can see here gx equal to 7x squared plus ln 5x to the power 1 over 3. So 1 over 3 is come from the transformation of square root of 3. So after that, we will differentiate our outer function. So we're going to take the power 1 over 3 and place it on the front. So as we can see here, there is 1 over 3 at the front of 7x squared plus ln 5x. Negative 2 over 3 is come from 1 over 3 subtract by 1, and then we got negative 2 over 3. After that, we will differentiate our inner function. So our inner function is 7x squared plus ln 5x. After differentiate it, we got 14x plus 5 over 5x. That 5 over 5x can be simplified to the 1 over x. So we're going to rearrange all of it, and for the final result or the final function, we got 14x plus 1 over x over 3 multiplied by 7x squared plus ln 5x to the power 2 over 3. So here we are at the second question of question 2. So the original function that given to us here is y equal to exponent 9x secant 6x. So the key to solve this question is product rule. For the first step of product rule, we're going to set up our u and v variable. So we can see here u equal to exponent 9x and v equal to secant 6x. And then we're going to differentiate these two variables. And then we got u prime equal to 9 exponent 9x and v prime equal to 6x, 6 secant 6x tangent 6x. To get the derivative of the original function, we need to use the equation here. dy over dx equal to u multiplied by v prime plus v multiplied by u prime. After that, we're going to substitute all the value here. That is exponent 9x multiplied by 6 secant 6x tangent 6x plus secant 6x multiplied by 9 exponent 9x. After that, we rearrange it and factor out some of it. And as we can see here, what we factor out here is 3 exponent 9x secant 6x. And what left in the bracket is 3 plus 2 tangent 6x. And that is our final answer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zafran Zaim Muhammad Arif. So today we will do the question 3. Given that exponent power of 2y minus 2 divided by x plus ln 8x equals to 7x plus y power of 3 minus cosecant 4x, we need to find the dy over dx using implicit differentiation. The first step is to differentiate both sides with respect to x. you can see there, we will write d over dx, and we just copy the question. We will write d over dx on the both sides, the left and the right side. The second step is to differentiate the left and right side. As you can see, the exponent power of 2y minus 2 divided by x, we will use the quotient rule as how we done it in question 2. So it will be 2x exponent 2y minus 2 dy over dx minus exponent 2y minus 2 divided by x square equals to 7 plus 3y square dy over dx plus 4 cosecant 4x cotangent 4x. Then step 3 will multiply with x square on the both sides to eliminate the x square in the denominators. So next, in the step 4, we will group all the term with dy dx on one side, which I do. I put all dy dx on the left side, and the variable with not dy over dx, I left it on the right side. Next, on the step 5, we will factor out dy over dx. So as you can see there, we factor out dy over dx times 2x exponent power of 2y minus 3x square y square equals to the variable with no dy over dx on the right side. Lastly, we'll let the dy dx on the one side. So we'll just keep the dy dx on the right side, and the other thing all we bring to the right side. And there you are, our answer.
So we go to the last question. Question 4 is about linear approximation and differential. You guys can read the question given. We to the point. 5 important thing we need to know and to do to answer this question. As we can see, we all know the value for x. The value for x is 16.88, and the fx just substitute the value to the x. So there are 3 things to find: the x naught, the fx naught, and the f prime x naught. First, we need to find the x naught using the second value in the equation. First step is to solve it. Just solve it and get 2.027. Next, we need to round it, and the value is 2. So how do we get 2 from the question? Just move the set to the other side, and it will be the 2 the power of 4. Solve it and get for the x naught is 16. Second, we just insert the value of x naught into the fx. We find the x naught from the equation before. So the answer is 2.25. Third, find the f prime x naught. Just differentiate as usual from the fx, and the answer is negative 1 over 2 x the power of negative 3 over 2 plus 1 over 4 x the power of negative 3 over 4. To find f prime x naught value, we just insert the value of x naught to the f prime x naught above equation of f prime x naught, and we will get 0.0234. Lastly, from the value that we find, we can conclude all the value to the formula. The formula is fx approximate fx naught plus fx naught multiply x minus x naught, and then we insert all the value to the formula and get the approximate answer in 4 decimal places. Just in 4 decimal places, and the final answer is 2.2706.
To sum up with, for the conclusion, differentiation is a key concept in calculus used to analyze how quantities change. It helps determine the rates of change, such as speed or growth, and finds the slope of a curve at any point, showing how a function behaves. Additionally, it's widely used in optimization to find maximum or minimum values, making it essential in solving real-world problems efficiently. As a reference, we refer from Workbook Calculus 1 prepared by Nur Bahia Awang. That's all from us. Thank you and bye-bye.